this lecture, we will discuss about LeNS design method and tools such as SPSS, MSDS, and DE. Well, a LeNS is Learning Network for Sustainability. It's an international a forum where a group of academicians, researchers, scholars such as you have become actually part of it. They develop actually sustainability assessment methods, tools, techniques, etc. They apply these into various cases from across the world. They prepare actually case studies, they share with each other, they publish actually research papers, books, and other resources which are crucial for understanding of sustainability in an overall sense, majorly targeting like a product design and some parts some cases like architecture also. So in this actually lecture we will discuss about evolution of sustainability within design. These are the contents. So hopping on with the first topic, increasing role of design for sustainability. Well, when we see the increasing role of design, for intervention into the design for sustainability approaches. So the greatest actually intervention is possible at the time of deciding the consumption pattern. Okay, so when we are actually looking for actually some kind of a product or a solution as a consumer, so the time that time actually that stage has the largest potential to minimize actually the consumption of resources, or the energy which will actually follow up for to satisfy or to fulfill our needs. So the largest potential for this improvement is right there at that particular stage, so that you can see in this graphic over here. So as the time goes from a conceptual stage till the work is actually done and the product is delivered or the service is rendered, so from the starting to the end, the largest potential is at the beginning itself, if you can correct. So remember the previous lecture what we had in the NBC chapter, so a minimal actually consumption, minimal actually waste that is possible through correcting our behavior, our habits itself. Second, intervening on product and services. So that's at the stage where we are designing or fabricating or manufacturing our product or rendering our services. At that time also we can use certain strategies to minimize the impact. Further, intervening on the processes. So the once actually the product or the system is in place and is under operation, so even at that stage we can minimize the consumption and minimize the energy uses. Further, in the last, intervening after products damages. So the for example, the once is product is a used, and it is left out or discarded, even by adopting certain strategies at that time, for example recycling, reusing, remanufacturing, etc., we can minimize up to a certain extent. So we saw that the largest potential for this improvement is right at the beginning stage. So you must focus more and more in the a beginning stage only, in the a conceptual itself stage itself. So the emphasis should be on the prevention, because rather than cure. So the cure is actually remedial actually method. Once the problem has arisen, then comes the cure. But prevention actually comes before the problem has arisen. So we must actually go for handling sustainability through using this approach, of emphasis on a prevention. So an emphasis on a social cultural dimension. So the sustainability actually involves all of these three ESG aspects, and it is very important to address and consider those aspects also. Well, the roles and responsibility for the technical definition of the solution and the attractiveness of the solution. So if you see there is actually a huge role for us to play over here, how we can define a situation, how we can actually elaborate a situation, how we can make it an attractive opportunity to actually deal with, or to actually go for a certain innovative solution in any given actually context. So what does the design community in general knows about design for sustainability? Let's see some examples. So we have this cardboard seat. Okay, so well, you may have seen actually such products around you, which use actually this kind of a material, so what kind of impact it can generate? Well, very minimal, right? So that what comes to our mind in a first glance. Okay, what comes to your mind after seeing this picture? It's actually a walnut wood chair. It's almost like has lived like a 500 years of life. you know so is it sustainable or not? Because this actually product is taken from like a tree. Okay, so if we go for like a conscious evaluation of these two products and whether they are environment friendly or not. So the first one looks, this one looks like environment friendly. This one doesn't looks like environment friendly. But if you compare, the time and the functionality, so how many, like a number of these cardboards are needed, to render the same service which this single product has served for like a long period of time. So there is actually a factor of time in this, if you see. So that is where actually this the product actually designed for like a longevity, and an extended lifespan comes into picture, where we consider actually an extended, actually an efficient, actually utilization period of that product. Because once that product is manufactured and ready for use, that must actually carry on its job for a longer period of time in order to prevent the second same product to come and replace the first one. So how we can actually minimize the need of the like a second product, up to an extended period of time. That is the task over here, that is actually idea over here, which I'm trying to explain. So you must actually assess your product, in terms of like a longevity, also how long it's going to serve. So on sustainability, like evaluation parameters, time is a very important factor, like how long a product is going to serve. You see, like this products example I have taken from like Herman Miller. Herman Miller is a famous like a furniture design and manufacturing company. So any like a random chair which we use in our like houses, it mostly lasts for like a 3 years, 4 years, maximum like 6 7 years or something like that. But this particular chair is designed to last for like a minimum 12 years, and the company offers a warranty also of like a 12 years. So that is a very new thing in this actually product domain. If we see, like no other furniture company offers like a 12 years of like a warranty period of their product. That means the company itself is like a confident enough that their product is going to long for a longer period of time. So that is where actually this the functionality of this time comes into like a consideration. So there should be actually a conscious effort from the manufacturers and the agencies who are supplying actually the product, so that they make a product which is like good enough, which is going to sustain the the test of time for a longer period of time. So like how many like a persons within the design community would evaluate correctly the environmental sustainability through this like a picture? How many of you can identify which product is sustainable or which product is not? It is very difficult to understand because there are several other dimensions. One we just now actually came across is the time. So there should be actually a conscious effort, and it has been actually developing for like a quite a like a number of like a years. So in the 1970s, it was like a the focus was on to like a low impact designs. Then in the 1990s, it came about life cycle design. Then in the 2000s, it came for like a SPSS service, sustainable product service system design. Then in the 2005, it came for the like a sustainable distributed economic model. So we will discuss the some of these in the like next slides, how it is evolving over the time. So the product design for environmental sustainability. So let's see, low environmental like impact materials or energies. Okay, so this we have been discussing in the previous lectures. So the material chosen should be non-toxic, natural, recyclable, renewable, and biodegradable. Because if any one of this is not met correctly, the product is going to have some kind of impact on the overall systems. If it is like a toxic, it's going to generate some kind of like a hazard for like some like a species. For example, even if a product is like a toxins, or if it emits like a VOCs, it is hazardous for the human uses also. Okay, if it is less toxic, it may be like a hazardous at a lesser actually proportion, but it may be harmful for like other organisms. Or if it is like a non-natural synthetic, then it will take a very difficult actually approach for the at the time of like say disintegration and decay and decomposition at the end of the life cycle stage. If it is like a non-recyclable, again it's going to last somewhere in the like a landfills. It is going to be there forever, for a very long period. We have studied about like acrylic and bakelite, etc. They cannot actually be degraded on their own for a very long period of time, sometimes running in up to like a 50,000 years. That's a huge actually span of time. Okay, so and renewability and biodegradability. So how this product life cycle actually approach works, if you see, like an extended like a design horizon from product design to the design of the product life cycle stages. So we must not design just the product, we design actually the life cycle stages of the product, so that the product is going to live for an extended period of time. Okay, it is like a taken care of for its like a degradation, or actually it's like a disintegration, so that it can be recycled, it can be like a reused, it can be dismantled, and also all of these actually process should be actually taken care of. Further, the design reference from product design to the products like a function design. So the product is not the actually ultimate object what we are looking for. The object behind a product is to satisfy a need, satisfy actually a requirement. So we must actually focus on that requirement, or that satisfaction which that product is going to create or generate. Okay, not the products. So we must actually orient our like needs around that need. Okay, not to the product, because product is just a means to satisfy actually that particular need. And the environmental design objective minimize the environmental impact of the whole of the phases in relation to the functional unit. So as we have seen, like the impact minimization is one of the very critical actually considerations, and that we can try from like a several actually approaches. So when we see like a product design life product life cycle design, which is can be called as like a eco design also, a piece of good news, it's available as well like a consolidated knowledge base and know-how, methods and tools to design environmentally sustainable products. But there is a bad news also. The design and offer of products really with low environmental impact is still like a extremely like a limited, or very like a a few in numbers. So well, there are like a number of products to fulfill a need. The moment you name our name like a product, there are n number of solutions available, but most of them, they are still having like a huge impact on the overall systems. So that we actually must take care of in our designs. On the third topic, sustainable product service systems, win-win opportunities for companies and organizations. Let's see how. So, what is sustainable product service system over here? Since the end of the 90s has been like studied some business cases offering as a full package of a mix of product not owned by the customer, and services show to be like a capable of creating a new value, decoupling it from the resource consumption. So what is it? We will see over here. Like for example, you may have seen like a photocopier machines. Okay, so the objective is to copy the or make the like a Xerox copies of like any document, or like taking like a photocopies of a or maybe taking a print or something that. Okay, so that is the main objective. But the objective is not to exactly own the Xerox actually machine or the photocopier machine. Okay, so the moment you start seeing a product as a like a service provider, as a like a facilitator, you will be like amazed to see like how a product actually should function. So for an extended period of time, if that Xerox machine, if that photocopier machine is going to serve you like satisfactorily, well, that is what you want. So for doing that, why you need to own a machine? So this experiment was actually conducted by this Xerox machine. You may be aware of this company. It's a very famous company from the photocopier actually copying business. So instead of like a photocopiers, they sold copied like a papers and documents. So Xerox actually offers a package deal and installs and maintain photocopiers, which is not owned by the customer, and may even makes and delivers copies. The customer pays for the like a package. So whatever like a amount of like a prints or the photocopies you need, well, that is what you have to pay for, not for the entire machine. So the machine will be loaned to you if you require in your premises, in your office, and that machine will still be the property of this Xerox company. Well, you can use the facility, and you can pay per like a print or per like a photocopy basis. So this is an actually, if you see, an innovative actually business model, offering ownerless actually photocopier machines with all inclusive life cycle services. Also, the company is actually responsible for maintenance operations, and in case some kind of like a repair is needed, or some like supplies are needed, like additional like cartridges and inks and paper, etc. So the company actually takes care of those actually things. But in the present actually scenario, whenever we buy a product, the liability of that company which has manufactured that product, ends in a very short span of time, which they call it as like a warranty period, which varies like generally from like 6 months to 1 year, up to like sometimes and rarely in like a few years. Okay. And after that, actually company doesn't provides free services, or it doesn't takes care of those like the components or the parts of it. It just even stops like supplying like a parts of it. For example, the biggest electronic like a brand like a Apple, which is very famous across the world, so it actually sells a state of the art like a computing machines, like a laptops, and pads and phones. So this Apple company actually sells these products with a warranty of like maybe 6 months to 1 year period usually. Okay. And it charges like a X amount for like an extended like a period of like a warranty, for example like 2 years. And after that, it doesn't extends that warranty, and leaves the customer, leaves the actually user in the lurch. If something, in case something goes wrong, they will charge a hefty actually amount to actually provide the service, as well as provide the like a components or the spare parts. And after like a 5 year or 6 year of like a period, they just render that product actually obsolete. They leave it, they call it, they starts calling that model as like a vintage model, and they actually stop producing or providing any kind of like a service or components or spare parts needed for that machines. So these actually Apple made machines are very heavy duty, very efficient, and very pricey machines. Okay. If you compare with any like a electronic available in the market, they charge like a twice to thrice, in some cases like a 4 times also. So for like a such a like a heavily priced machine, is it justified to have like such a short period of like a warranty period, or stopping the even supply of like a services and spare, for that product? So with this way, if you see, Apple is really bad on doing like a sustainability aspects of like these products, and this company unintentionally or intentionally, whatever, that needs to be seen or checked, is promoting actually a lot of like a huge electronic waste, and is a burdening customer to buy actually new models, indirectly. So that is actually illegitimate actually way of promoting actually this product consumption in the masses. So the responsibility of the company, the responsibility of the like products uses also lies with the manufacturing company. It should not end with the moment the product is sold. The responsibility of the company should not also end. So that is the consideration being actually said over here. What if the service of that product, is actually this sellable actually thing, not the product itself? So what if these company, they start actually loaning us like electronic like equipment and gadgets, and we keep them using for like a x amount of like a time, and we kind of give it back to the company if we do not want to use it any longer, if we want, or if we want to like buy like a new model or something like that. So in that case, actually the charge will be like a per like a time usage or something like that. So this actually concept is called as the product service system, where actually service becomes the main actually criteria of like a payment. So in such actually scenario of like a product service system based approach, the responsibility of the company changes dramatically. Now the company is responsible to maintaining actually that product. So they will design their product to last for like a longer period of time. And that is what precisely this Xerox company did, which is a very novel idea. Like they made actually efficient machines which lasted for a very long period of time, very extended period of time. So with the same like a machine, they were able to render services for an extended period of time, in turn actually saving on like a manufacturing several machines which may actually be serving in that actually a number of years. So this is actually called SPSS, service sustainable product service system. So further, like how you see what is the like a sellable. So in a like a conventional, actually a traditional like a product sale actually system, so the sale is of the product. But in a sustainable product service system, you see in this illustration over here on this slide, the sale is of the satisfaction unit. Okay, so we are not selling the product, we are selling the satisfactory actually consumption or the uses of it. So what is the innovating actually point? If you see in the conventional like a product sales system, the technology is the actually innovative actually point. But in this SPSS system, if you see, interaction of the actors becomes the actually a point of innovation. And on the what is the actually value received by the customer? If you see the value what we receive by buying a product is that we become the actually owner of that product. But in this one, actually there is actually a group sharing or a common sharing, or the excess actually becomes the actually the value which we get out of like a such kind of actually satisfaction system. So this is what actually SPSS is. So the economic interest of the manufacturer fosters the design of the environmentally sustainable products. So this is how actually the company becomes responsible for the actually longer period of usage or the consumption of that particular product. So of course they will be maximizing the efficiency or the longevity of that products. Okay, which in turn will lead us to the several aspects of like several strategies of this sustainability can be achieved. For example, if it promotes like reuses, then we can go for actually optimizing on the like a usage part, services part, the usage part. Further on the collection part, if you responsible actually disposing system, it can actually avoid landfills and incineration in a shorter period of time. The product can be utilized for like a longer period of time. On the pre-production stage, if you see, even the energy efficiency can be achieved, because the company will be responsible to make it efficient on resources and the energy consumption, and energy extraction also. So the we can say, if we are using the one product for like a lifespan of like a two, like a average product, then we are at least saving the resources which were needed to manufacture the second unit of product. Okay, so that is how we will actually save on the resource consumption also. On the production part, if you see like the finishing, assembly, manufacturing, so these also will be actually having like a efficient actually impact. And on the distribution, the storage, transportation, packaging, so there will be saving, as you can see on these parts also. So in an overall, actually, if you see this the life cycle of a stage, there will be saving in each and actually domain of it. So there in an overall sense, this SPSS has the potential to minimize the impact in an overall sense. So the design for actually materials consumption minimization, design for like energy consumption minimization, resources renewability and biocompatibility, for resources toxicity and harmfulness minimization, for products lifespan extension, for the maintenance, repair, upgrade, remanufacturing, reuse, intensification, etc., for recycling, composting, energy recovery, design for disassembly. So these are the actually approaches, these are the actually strategies which SPSS has the potential to actually address to. Further, if you see, are the like sustainable product service systems also applicable to low and medium income contexts? Let's see. Are they promising models to economically foster and even social equity? And are they win-win models for fostering all of the sustainability dimension? Well, it has the potential to cater to like this like a low or medium income context. Also, it can actually be taken up at any level. We will discuss with some examples in the like coming slides. So yeah, so this actually book gives us an extensive actually detail. It has a set of like articles which are written by like several like scientists and actually designers from across the world, which will be helpful in understanding this SPSS system through this book. You can refer actually this book when you are free after this class. So, a sustainable product service system, an offer model providing an integrated mix of products and services that are together able to deliver a unit of satisfaction or fulfill a particular customer demand, based on innovative interaction between the stakeholders of the value production and satisfaction system, where the ownership of the product and the and or the like a direct cost of its life cycle services remain by the providers are being actually paid per unit of satisfaction, so that the economic interest of the providers continuously seeks environmentally and socio-ethically beneficial new solutions. So this is actually intention of the SPSS, and that is how actually we see there is a huge actually potential by adopting SPSS system in our like consumeristic actually product domain. So in the next topic, let's see what is the distributed economy, DES, a promising model for locally based sustainability. So we have seen in the previous lectures like how this globalization has brought actually several kinds of like repercussions, and the impact of any product which is being manufactured in one corner of the world has increased, because of this indirect emissions which are happening there due to this transportation, and things. So how this distributed economy actually works. So since 2005, some models have been studied as a promising model for locally based sustainability. Distributed economies, selective share of production distributed to regions where activities are organized in the form of small scale flexible units that are synergetically connected with each other. The concept calls for a transformation in the industrial system towards DE, departing from the socio-economically and environmentally unsustainable dynamic associated with the large-scale centralized production units that are favored by neoclassical economic drivers. So how it works, you see this, I would like to explain you through this some examples. For example, we have like this centralized like a power plants, for example like a coal based power plant, or maybe hydroelectric power plants, or maybe nuclear power plants, or so on. So they actually generate a huge actually quantity of like a power, and they supply for like a larger actually area. But compared to this, if we go for like a smaller actually power generation units, for example like a home based solar power grids, or maybe a neighborhood based actually power generation grids, or maybe a city based actually power generation like a network, so the impact of this will be lesser. Why? Because the footprint, because the ecological footprint of like a project of like this scale is very high. Okay, now if you divide it into like a smaller actually unit, so the overall impact can be minimized. So this is where actually this distributed economic models comes into the like a power generation system. So this is called a distributed energy generation system. So it is in place of like a one centralized very huge actually power plant, we can go for actually minimal smaller actually unit based actually power generation like a systems. So this is what it means over here. Another example for like a centralized manufacturing units based on maybe one country supplying to like to the n number of countries. Why can't we have actually this economy distributed actually manufacturing systems also in place to have like a distributed like a manufacturing facilities, at like most of the places in most of our like almost like every state. Why can't we have like such facilities? Because for having actually centralized manufacturing facilities, there is a larger impact on the like a social sector also. The workforce is forced to move from like their native places to these actually centers, or these actually focal points where these manufacturing units are actually established. So this is how this distributed economic model looks like. You can see in this illustration over here, which like gives a picture of like a paradigm shift from like a centralized large production units and distribution system to a decentralized or a distributed actually model. So if you see from like a centralized to decentralized to distributed, so these are the three verticals over here which explains this actually concept graphically. So the how the structure is, so the structure in the centralized actually system is like a hierarchical control is there. In decentralized there are like a no intermediaries. In the distributed it is like a under like a distributed control. So you can see like this one actually centralized system is controlling all of these actually domains, and here there are like a smaller but decentralized actually domains, like some things are actually handled by this one, some actually few things are handled by like this actually decentralized actually node, But in this one, if you see, the units are actually these, centralized units are actually defragmented into like a smaller units, and all of them are actually operating independently in different locations. So they are actually distributed actually at different, actually a larger actually area, so that they can serve locally in an efficient manner. So this is how actually this visualization is. And even for the like a consumption part, for example, like a resource consumption, energy consumption, or like other types of like a utilization of like a manpower, so that also will get actually distributed. So the impact on the surrounding will be relatively or comparatively will be very low. For example, if a manufacturing unit is defragmented into like a 10 smaller units, so the kind of resources which it going to like extract from the surrounding will also get distributed at those 10 actually different locations. So the overall impact, compared to like a the one bigger company which will extract the equal number of like a volume of those resources from the one place, will also get distributed at 10 different places. So the overall the resources needed for these 10 different places will get distributed in these actually 10 places, so minimizing the impact. Further, like energy consumption, or for example like a water consumption. So a factory, or maybe a water bottling plant, or maybe a drink actually manufacturing or making company, which is located at one place, may actually take like a huge amount of like a water from the like a ground, under the underground, for at one place. If we distribute it at a number of like location, so the impact on those every location will get divided by that number n. So this is what actually this concept is. This is what it is actually talking about. So for the like energy, food, water, manufacturing, software, knowledge, for everything, even for the like a design, if we go for like a distributed actually approach, even for like a designing, so design can take place more effectively in that actually location for wherever we are designing. Like we have studied like this vernacular architecture, vernacular design, so that particular design serves to that place. So the resource person from actually that area may be able to understand actually that philosophy, of vernacularity in a more effective way, so that person can actually help building the design process or the design methodology in a more effective way. So this is what actually it looks like on the size and proximity. If you see, like this centralized system works in a very far from like an end user, and in a very large format. This decentralized actually system works to like a smaller actually scale, but almost near to the end user. But this one is works at the even like a smaller level, and by the end user. So this is where actually this difference is. So the small scale locally based production units empowering end user controls on like essential activities, more interested safeguarding local environment. So this is how actually this concept looks like of like a SPSS. Further, when we see over here, so the selling point from conventional approach, from like a product to like a unit of satisfaction, for innovation from technology to stakeholder configuration, from the like a customers like a value, individual ownership to like a access to that product or services. So this is what actually SPSS is. And compared to this, this is what actually this distributed economic model is, from like a hierarchical centralized model to a distributed model. So these are the actually two philosophies what we were actually discussing in this lecture. So locally based sustainable opportunities in low middle income, or kind of like a all context, so which can be utilized. So one more example I would like to bring to actually show you here is about this off-grid actually electric system. It's a home-based actually solar system, to provide power to the families. So this actually M Power company offers to Tanzania rural people a solar home system, SHS, which includes the hardware to generate solar energy, solar panel plus storage plus wires, energy using like a products EUP, two lights, phone charger, etc. Customers pay as like a pay per period, like on a daily basis. Off-grid electric retains the ownership of these SHS and EUPs. Cutting initial and life cycle cost of such hardware makes it accessible and sustainable in time to low income people and organizations, and in an overall sense for like everybody. For example, like these harvesting like a solar energy is a very green concept, but it comes with a technical actually issue of a maintaining of the like a battery part, which is going to store that electricity power for consumption in the night time. So if the company has the ownership of those batteries, they will be taking care of then extended like a longevity, maintenance, repair if needed, or even like a replacement if the need is. So if the ownership remains of this product with the company, they will be in a better position to keep it running for a longer period of time. But we have seen like how this novel approach is, this was adopted even from like our state, several state governments, also government of India also like a few years ago. But whoever have bought actually these products, now these products are actually thrown, they are not in use any longer. So they are in turn generating a huge amount of waste, and that too like a toxic waste. These batteries which store actually electricity, they are very hazardous in nature, and once discarded irresponsibly, they are going to create actually a huge impact in the ecosystem. So how we can save on through like such impacts also through this SPSS system is one of the beautiful actually examples to talk about here. So let's discuss the next topic, which talks about a system design for sustainability, a new role for designers. So what is the system design we will discuss over here. Design for design approaches and skills organization from the like a sustainable system approach, design the satisfaction of a particular demand, unit of satisfaction and all its related products and services. Stakeholder configuration approach, design the interaction of the stakeholder of a particular satisfaction system. And then system sustainability approach, so design such a like a stakeholder interaction, this model that the economic regions continuously seek after both environmentally and socio-ethically beneficial new solutions. So any product, like we have discussed earlier, doesn't sit in isolation. Every solution is meant for people, it is utilized by the people, and there are number of like stakeholders who are involved in like a fabrication, or the resource actually sourcing, then the power generation, then operations, the usage, and the disposal. So all of these stakeholders, if we combine them into like a one unit, and if we design our like a product and the service system in such a way that it serves the system efficiently, and if there is any needed to improve the entire system, so if for that actually we can intervene at that actually stakeholder level, or that actually unit level, to improve the efficiency of that product, and in turn we can actually improve the efficiency of the entire systems. So that is where actually this system sustainability comes into the picture. By intervening at one actually stakeholder or one level, how we can improve the entire actually system around that product. So this is what it talks about. Good news in this actually area, it's available as like a knowledge base and know-how, methods and tools to design sustainable product service systems, recently developed for like SPSS applied to distributed economies. But there are some challenges also. Design and the offer of win-win sustainable product service systems with is still like a very limited. So we have seen some solutions which certain companies are offering in the market, but they are very limited, very few in number. So this the direct product selling approach is still actually has the major share. Rather, the SPSS almost has like a negligible presence in the entire economic actually model of that like today's like a society. So how this share can be improved is a matter of discussion now, how this efficiency can be brought in. So state of the art, like given the great opportunities and responsibilities, as well as the new knowledge base and know-how developed for the designers, today few within the design community are equipped with a solid knowledge base and know-how on like a design for sustainability. Today the design community as a whole is still more part of the problem than part of the solution. So how this can be improved is a matter of discussion. How you can adopt these strategies, adopt these approaches while you are designing your projects. So this must actually get incorporated in your thinking, in your like a thought process for going about like any project. So from here and onward we will discuss about certain strategies of like a sustainability design in like our product design domain. So one by one we will talk about product environmental effects and requirements, life cycle assessment, product life cycle design for like a life cycle and functional approach for strategic and guidelines approaches, methods and tools. So let's move on to the first one under like this series, the sixth topic of discussion under this lecture, product environmental effects and requirements. So what are the environmental requirements? It is to design for minimizing products environmental impacts, environmental damaging effects, so the each environmental effect is based on a substances exchange, between the nature and the environment and a process of a production and consumption system, so this is how actually the interaction of the material is happening. We are sourcing it from nature, we are processing it, again we are throwing it back into the nature. So how, what kind of like impacts are being generated, that is like a very much evident, like it is not going as like desired. So the input, in the inputs, like substance extraction from the environment, output substance emission in the environment. So these are the two things happening on. So we discussed in the like a life cycle stage, any life cycle of a product, or any product consumes like a resources in its like a input side, and and it excretes, it exhausts actually certain like things as a like a output, as a like a effect of like a that processing, and at the maybe end of the life cycle stage of that product and all. So that becomes actually forms the output part. Okay, so inputs and their like a damaging environmental effects. Well, resource exhaustion, first of all, first and foremost, so resources are getting depleted. Alteration of the ecosystems like a balance, so the balance is actually getting actually disturbed. For example, like if we are extracting water, from the like a aquifers below the like a earth surface, those aquifers are getting actually dried, and then the water table in the entire area is gradually actually have started like a going down, and several like a cities, countries, are facing actually this problem in the recent times, that there is no actually groundwater available for like a several hundred feet in the ground. Okay, so these are the actually damaging outputs of like extraction like processes, you know outputs and their damaging environmental impacts. Well, of course we are all aware of global warming, stratospheric zone depletion is happening, acidification is happening, the acid rain, like a terrestrial and freshwater disturbances are also happening in the freshwater, ocean acidification, winter smog, the suspended like a particulate matter in the air, summer smog, photochemical ozone formation, etc. Eutrophication, human toxicity like a carcinogens and other like a sorts of like a disease causing actually compounds are in the atmosphere these days, and of course the waste. So these are the actually some bad actually outputs. Further, what is life cycle assessment? So let's have a quick look. Can we associate the environmental effects to a product? Well, how? Okay, so the approach is, product life cycle approach or functional unit. Evaluation method is like a LCA. So we have discussed the LCA before, like how we can apply to any like a given product, and how we can assess the stakeholders and that entire actually system. So you can see over here, this is actually a diagram of like a products like a life cycle, stages. So starting from like a, if you see like a pre-production, to production, to distribution, to usage, then again like a disposing. So from here we are starting this whole process, so in this like a segment, you see like there is a resource extraction, material energy goes into the like producing it, and then for like a production stage it goes for like a final manufacturing, assembly, finishing, etc. And then again is for the distribution, packaging, transportation, storage, the uses part of it, the actually consumption part of it, then it goes for the like a collection once the life expectancy is over. Once the usage is actually completed and fulfilled, then it goes for like a again like a recycling, reusing, and etc., or maybe ends up in the landfill. Okay, so this is where actually this disposing actually approach comes, so this is how it actually it works like a normally. So what is like a functional unit? Well, is a functional unit is not the product to be designed or assembled, or SS, but the whole of the processes associated with the fulfillment of giving a function. So the functional unit is a quantified performance of the product that is being assessed to use as a reference unit within an environmental impact assessment of all its life cycle stages. So remember we spoke of like SPSS. So this is related with that SPSS. We are talking about the functional unit of like a product in terms of fulfilling the service of it. So, what is a life cycle assessment? Well, it is a quantitative method to model and assess the environmental effects of a given product throughout its life cycle and in relation to its like a functional unit. So, LCA is an internationally recognized method. Its practice is guided by international standards ISO 14040 LCA series. So, like for example, it is given over here life cycle assessment of like a coffee maker. Well, it allows us to quantify the environmental effects a product is responsible for. So you see on these like a three like assessments over here, what are the possible actually damages, impacts, and after effects caused by a simple product such as like a coffee maker. Okay, so like the ecological damages, well, global warming, eutrophication, acid rains, ecotoxicity, habitat alteration. The human health damages actually part. So health damaging like substances, photochemical smog and air pollutants, carcinogens, ozone depletion. On the resource depletion part, well, it's causing like a consumption of fossil fuels, water, minerals, and several other things. So this is how actually we can further we can take help of like some softwares which are recommended for like this life cycle analysis, and we can carry out an in-depth actually analysis of like how the components of this as like a unique product actually are sourced from, how much energy invested, how much of like a material is invested, how much of energy is going to consume in its overall like a life cycle, in its like operation phase, and what are the kind of after effects at the end of its life cycle. Further, in the eighth actually topic of discussion, well, product life cycle design, life cycle, and functional approach. So here, we will talk about this like a life cycle design, which can be called as like a eco design also, or design for the environment. These are the actually synonyms. Okay, so the disciplines integrating environmental requirements within the product design process. So here, if you see like the approach, an extended design horizon. Okay, from product design to the design of the product life cycle stages. So this is what we actually focusing on. We are not just designing the product, we are designing the life cycle of that product. So the design reference from like a product design to the product's function design. So we have discussed in the SPSS. That is what actually this this approach of this SPSS is further actually bifurcated and made into like a actionable points. For example, if you are going to design like a product, for example, a milk actually packaging actually unit, then how we can do it, how we can think of it as a not an end product. For example, like currently whenever we buy a packet of milk, okay, we end up with that actually packaging also. Okay, so how can we actually go for a service based actually solution, a product service based solution, so that our objective, our actually requirement is to receive the milk, okay, not the actually packaging part. So how we can receive the milk, as well as still at the same time we can manage to give the packaging back to the manufacturer or the company, and there it can be again taken care of for like a recycling or reusing, or things like that. So this is where what actually we are talking about, designing for the like a life cycle stages, designing for like a products like a functional design. Okay, the environmental design objective, minimize the environmental impact of the whole of the phases in relation to the functional units. Well, that's the overall actually purpose of this exercise. So some actually papers and literatures are given under in this book. Maybe you can refer it in your free time. The design of the like a product life cycle stage is that, while considering all requirements, aims at minimizing the environmental impact of the whole of the life cycle phases in relation to the functional unit. So this is what actually it means. Further, in the next topic, we will discuss about product life cycle design strategies and guidelines. So what are the strategies we can actually apply in our designs? So here we will actually see some examples in detail, and we will discuss about some strategies in detail. So low actually cost actually low life cycle impact actually design. So on the environmental studies, minimizing material consumption, minimizing energy consumption, optimizing resource renewability and biocompatibility, minimizing resources toxicity and harmfulness, product lifespan of optimization, extending the life cycle lifespan of the materials, and design for disassembly. Well, these strategies we have discussed in detail earlier. We will see in more detail in these coming slides. So for example, if you see like this electric guitar as like a product, so what is the approach do you see compared to these actually figures over here, these two pictures over here? Well, of course, minimizing the material content of that product. Okay, so this is the approach adopted in this actually like equipment. Well, it's done for the like aesthetical purpose also, but at the same time it solves the problem of like a resource minimization also, because for an electric guitar you doesn't need actually this volume to resonate actually and create that sound effect with this actually box generates while playing the guitar. Okay, so why while like how by removing actually this actually material over here, we can minimize the actually consumption of like this wood, because this is actually like these guitars are actually made naturally by using like wood, so the how this this kind of design can minimize the consumption of the material. So dematerializing the product or some of its components, so that's the objective in like one of the strategies which we are talking about here, about like a material minimization. Okay, so this is one example over here. Further in the like a discussion part, like minimizing material consumption. Well, how? So minimizing material content of a product, dematerialize the product or some of its components, digitalize the product or some of its components, miniaturize, maybe reduce in the scale and the proportions, avoid oversized dimensions, reduce thicknesses, apply ribbed structures to increase structural stiffness, avoid extra components with little functionality. So like, these are this seems to be very commonsensical actually approach and ideas, but this is very important for us to consider while we are on the drawing stage, while we are on the conceptualizing state for like any like a product design. Further, minimizing scraps and discards, select processes that reduce scraps and discarded material during the production. Engage simulation systems to optimize transformation processes. Further, like a minimize or avoid packaging. Avoid packaging first of all. Apply materials only where absolutely necessary. Otherwise, do not use like a packaging materials. Design the package to be part or to become the part of the product, so that the moment the product is delivered to the user, the packaging usually gets discarded immediately. So the lifespan of like a packaging material is comparatively like a very short, compared to the product. So how this disparity can be actually minimized, so that is the actually objective over here. Further, this strategy of like a minimizing material consumption during uses. So design for more efficient consumption of operational materials, design for more efficient supply of raw materials, design for more efficient use of maintenance materials, design systems for consumption of passive materials, which doesn't utilizes energy extensively, design for cascading recycling systems, facilitate the user to reduce material consumption, set the product's default state at minimal materials consumption. So anyways, like for example, we have these the like automobiles, so they keep consuming like a fuel for their entire lifespan. So the how this the efficiency of this fuel consumption can be increased. So this is what we are actually talking about over here, minimizing the materials consumption during the usage period. Further, in the next strategy, adopt flexible material consumption systems like during uses. So engage digital support systems with dynamic configuration, design dynamic material consumption for different operational stages, engage sensors to adjust materials consumption according to differentiated operational stages, reduce resource consumption in the product's default state. So this is how actually we can go for a flexible material consumption system also during the operations stage. Finally, this strategy of minimizing material consumption during the product development phase. So minimizing the consumption of stationary goods and their packaging, engaging like a digital tools in designing, modeling, and prototyping, engaging like a digital tools for documentation, communication, and presentation. So the kind of stuff we do in our like a studios and classroom. So how we can minimize on the stationary, and how we can minimize on the other like a support like a materials, and how we can go like a as much as possible like a digital. So for like a designing also we can go for digital sketching, a digital 3D modeling, digital like a prototyping, digital like a simulation, and testing. And then finally if need is there, then we can go for the final like a material based like a prototyping and experiments. Okay, so in turn we will end up actually reducing the materials required for like a product development phase. So see the kind of potential this actually exercise has is really immense, and it's really eye-opening for you as a like a designer. So you should employ actually such strategies in your like design exercises. Further we will see for energy minimizing energy consumption in the like products. So we have actually this case example over here. So the objective, the strategy is designed for like a energy minimization. So the example of select the most efficient energy consumption system during uses. So design system for consumption of passive energy sources. Okay, so it's a simple actually fridge, the refrigerator given over here. So this free up fridge with the passive use of the outdoor cold. So how this actually fridge uses the actually outside cold for the like, which is like a normally there in the like a colder countries, and reduces the actually energy demand. So this is why actually this example is given over here, that it utilizes the outside actually chilly weather to create this cold actually atmosphere inside this fridge. Further, so what are the strategies we can go for considering while we are thinking about minimizing energy consumption? So that there are actually 5 strategies given over here. We will discuss one by one. Minimize energy consumption during pre-production and production stages. So what are the smaller like finer strategies which can be adopted for this? Like select materials with low energy intensity, of course. So the material intensity of the product should be lesser, like we have discussed like alloys, and polymers. These are really energy intensive material. They actually consume a lot of power, a lot of like energy, in their like production stages. So if it is possible to go for like other like alternative materials for like such in energy intensive material, we must actually go for those. Select processing technologies with the lowest energy consumption possible, this consumption pattern. We should go for energy efficient machinery. Use heat emitted in certain processes for preheating other like a process flow, so the energy wasted in some like a process can be utilized for the other process. So this kind of like approach. Engage the pump and motor speed regulators with dynamic configuration. You may have seen actually some examples where the bicycles are actually fitted with the dynamos. So the kinetic energy of that wheel, can be utilized by that dynamo to create through generate actually power, needed to light the bulb which is installed in that cycle. So that is actually what we are talking about over here. The energy wasted in like some actually industrial process, some process can be utilized for the other process. Further, equip the machinery with intelligent power off utilities, so that there is no power wasted once the machine is not in the use. Optimize the overall dimensions of the engine, facilitate engine maintenance. Define accurately the tolerance parameters, optimize the volumes of required real estate. Optimize stock taking systems. Optimize transportation systems and scale down the weight and dimensions of all transportable materials and semi products. Engage efficient general heating, illumination and ventilation in the buildings. So these are actually several methods, several actually finer like strategies through which we can go on energy like a consumption reduction in the like a pre-production and production stages. Further towards the like a next stage, minimizing energy consumption during transportation and storage. So design compact products with high storage density, so that every square inch, every like a volume inch is actually used for like a transportation, and the efficient actually transportation of the stuff. Okay, so that we can maximize the uses of the like out of the like a fuel consumed. design concentrated products, equip products with the on-site assembly, scale down the product weight, scale down the packaging weight, decentralize activities to reduce transportation volumes, select local material and energy sources. So these could be the actually strategies for like a minimizing energy consumption in transportation and user stage. Further, the third strategy of like select the most efficient energy consumption system during the use. So while using, we must actually use like a energy saving actually methods and strategies. So design products for collective use, design for energy efficient operational stages, design for energy efficient maintenance, design systems for like consumption of passive energy sources, engage highly efficient energy conversion systems, design or engage like highly efficient engines, design or engage like highly efficient power transmission, use highly bulked materials and technical components, design for localized energy supply, scale down the weight of transportable goods, design energy recovery system, design energy saving system. So these are actually strategies needed for like reducing energy efficiency, reducing actually energy consumption, sorry, in the usage actually period. Further, we have this fourth strategy: enable a variable consumption of energy to follow demand fluctuations. So engage digital dynamic support system, design dynamic energy consumption system for differentiated operational stages, engage sensors to adjust the consumption during the differential operational stages, equip machinery with intelligent power off utilities, program product default state at minimal energy consumption, and finally we have this fifth strategy of minimizing energy consumption during product development stage. So engaging like efficient workplace heating, illumination and ventilation systems, engaging like digital tools for communicating with the remote working sites. So these are the very exhaustive actually strategies, list of the strategies you can see, which are designed specifically, which are actually laid out here specifically for various life stages of like a product, and how and where I think we should make actually this intervention to minimize the impact, and minimizing the actually energy consumption is the actually idea being discussed over here. So the next strategy over here is designed for minimizing resources toxicity and harmfulness. So in an overall like a life cycle stages of like a product, so minimizing material toxicity and harmfulness, minimizing energy toxicity and harmfulness. So let's see one example over here. So we have this example of this actually microfiber like rags for like a home cleaning. Okay, so it says like a select non-toxic or harmful like harmless material, design products that do not consume toxic and harmful actually materials, rags for like home cleaning in microfiber, no need for like detergents. So if we actually see this like a fiber over here, so this has this capacity to wipe out the dirt and the kind of like a waste material which we want to like wipe our like utensils and surfaces like a clean in like a kitchen. Okay, so this material doesn't requires actually detergents in general. So how the quality of the material itself can be made actually useful for creating actually the harmless actually materials, because detergents and other like cleaning agents, they are somehow actually carry this toxicity, some actually amount of like toxicity in them. Further, environmental impacts of like a material, so depends on like a material specific characteristics, characteristics given to product. Okay, so the ranking from like a best to the worst is so this could be like a misleading, so an in-depth actually analysis is needed. So let's see what are the strategies for like such situations. So minimizing like a resources toxicity and harmfulness, so under that there are two like a major strategies. Okay, we will see one by one. So select non-toxic and harmless materials, avoid toxic or harmful materials for product components, minimize the hazards of toxic and harmful materials, avoid materials that emit toxic or harmful substances during pre-production, avoid additives that emit toxic or harmful substances such as VOCs we have discussed, the paints and other like a finishing materials used in the furniture and like interior surfaces. Avoid technologies that process toxic and harmful materials, avoid toxic or harmful surface treatments, avoid products that do not consume toxic and harmful like materials, And avoid materials that emit toxic or harmful like substances during usage. Avoid materials that emit toxic or harmful substances during disposal. So based on the like a life cycle stages, we can go for actually each and every stage, and we can rework, so that the overall minimization in toxicity can be addressed at all those levels. Finally, select non-toxic and harmless energy resources. So select energy resources that reduce the dangerous emissions during like a pre-production and production stages. Select energy resources that reduce dangerous emissions during like a distribution stages, during like a usage stage, and during the resource that reduces dangerous residues and toxic and harmful waste also at the end of its life cycle stage. So these are the actually stage approaches which could be utilized for reducing the toxicity and reducing the actually waste. Finally, we have this design for optimizing resource renewability and biocompatibility. So optimizing material renewability and biocompatibility, optimizing energy renewability and biocompatibility. So we are seeing there are always like a two components to any such analysis. One is on the material and resources part, and second is on the energy part. So we have to keep focusing on both of these actually components. Let's see one example over here. So for a design for a renewability and biocompatibility, select renewable and biocompatible energy resources. Use renewable energy resources. So this is actually solar lawn mower, because this grass cutting this machines, usually what we use in our homes, they are actually either driven by hydrocarbons, or maybe they use electricity from the grid. So is it possible that we can go for such solution, so that this keeps on actually moving actually this grass on a regular interval, and utilizes only this actually solar energy, because most of these times this operates in the daytime and it remains outside. So the design can be actually facilitated in such a way that it can be designed in a weatherproof manner, which remains outside, which actually takes care of its own recharging. It takes care of the moving of this lawn. So this is one very simple solution what we are talking about over here. Another, if you see, select renewable and biocompatible materials. Use biodegradable materials for a compostable products, pots for plants, and made of a cornstarch biodegradable polymer by Nova Mode. So this is the one actually a particular company and particular product we are talking about over here. So well, plastic has impregnated in most of our products these days. So if it is possible, why can't we use a starch based a biodegradable polymers, which at the end of their life cycle, if they can go without leaving any toxic residues in the ecosystem. So we are talking about here a resource renewability, which depends on regrowing specific speed, extraction frequency. So a resource is renewable if a context related, if anthropic a consumption rate, is lesser than the natural regrowing rate. So the nature has actually this replenishing actually capacity for natural elements. So but there is always a threshold. So the our consumption, we discussed in the one of the previous lectures, the biocapacity and the actually overall actually a footprint of the a growth and development, so that should not actually exceed the biocapacity. Well, most of the products in today's time are actually doing that. So how this consumption rate can be lowered, compared to the natural a regrowing rate and natural a replenishment rate. So that is the actually the thing what we are talking about over here. So under this renewability and biocompatibility a discussion, we have two major strategies over here to talk about. Select renewable and biocompatible materials, and select renewable and biocompatible energy sources. So in this one, use renewable materials, avoid exhaustive materials, use residual materials of production processes, use retrieved components from disposed products, use recycled materials alone or combined with primary materials, use biodegradable materials. Finally, in this actually strategy, we have use renewable energy resources, engage the cascade approach, select energy resources with high second order efficiency. Further moving on, like product lifespan optimization, how the longevity can be extended, how the product can be made actually serviceable for a longer period of time, minimizing the need of like a additional or the second unit of the same material. So design for product component lifespan extension, design for like component use like a intensification. So we will see in this illustration over here. So if you see like for the like a short product and component life from pre-production to production to distribution and uses, how this effect can actually can actually enhance the longevity of like any like a product and system. So if you see on this parameter, new technologies and techniques with the lower resources use consumption. Okay, so this is the actually at the end of it they go for the disposal, and the same function in time if you see. So the disposal and the usage comes, the disposal actually is relatively smaller, the usage is actually longer, then comes the distribution, production and pre-production. So it gets actually inverted, so actually updating of the like a component causing like a resource consumption. So here if we see the time span actually like a required for actually a product to like a function and gets like a at the end of its life cycle, that can be actually extended, so that the need for like another actually item, this another like a same product can be actually minimized. For example, if you see over here, this is a beautiful example actually taken from like a home based actually furniture. So the see the how the adaptability is actually utilized over here as one of the like a strategic points, and the product's life cycle, the product actually the longevity of product is extended for a longer period of time. So you see the child over here, this child actually has grown into this like a girl, and now further like in her like a young age. So the same set of these like components of this product, they are actually designed in such a way that they can be like changed, by the combination of this they can be changed into like a another set of like a product. So this actually has turned into like a table over here and another like a study table over here over like a period of time. So design multifunctional and reconfigurable products to facilitate their adaptability for changing cultural and physical characteristics. Okay, so like if you see like this is struck can be transformed from like a changeable table to like a table for like a kids to a desk for like a young people. So this is how the same product, by rearranging its component in like a certain way, it gets like a additional like a usage in it. So that is an like, extended actually lifespan of product. So how this lifespan actually optimization can be done? So there are some strategies listed down over here, like designing appropriate like lifespan. So design durable components, choosing materials and appropriate ways to preserve performances in relationship with the foreseen uses condition. Design components with extensive lifespan. Design lifespan of replaceable components according to scheduled duration. Select durable materials according to the product performance and lifespan. Avoid selecting durable materials for temporary products or component. Further, we have a strategy of design for reliability. So reduce overall number of components so that the system remains simpler. Simplify the product. Eliminate weak license. Eliminate the weaker components. Further, the third strategy over here is facilitate upgrading and adaptability. Well, how you can do, like there are some points given over here. Enable and facilitate software upgrade. Enable and facilitate hardware upgrade. Design modular and dynamically configured products to facilitate their adaptability for changing environments. Design multifunctional and dynamically configured products to facilitate their adaptability for changing cultural and physical individual backgrounds. Design products that can be upgraded and adapted on site. Design complementary tools and documentation for product upgrade and upgradation. So at the end of the like a normal like a lifespan of that product, there should be some support so that that product can be upgraded into a new product. So there's such actually knowledge sources, such actually these complementary tools and documentation must be actually given along with that product at the time of the purchase. Finally, we have this strategic like a this point of like a facilitate maintenance. So simplify access and disassembly to components to be like a maintain. Avoid narrow slits and holes to facilitate access for like a cleaning. Pre-arrange and facilitate the substitution of short-lived components. Equip the product with easily usable tools for maintenance. Equip products with diagnostic and or auto diagnostic systems for maintainable components. Design products for easy on-site maintenance, enabling parts cleaning and or replacements. Design complementary maintenance tools and documentation. Design products that need less maintenance. So of course, by designing products which require lesser maintenance and repairing, we can optimize on the overall efficiency of that product and overall longevity of that product. Further, in this we have four more strategies over here: facilitate repairs, facilitate reuse, facilitate remanufacturing, intensify uses. So arrange and facilitate disassembly and reattachment of easily damageable components. Design components according to standards so that they can fit from like one product to another. Equip products with automatic damage diagnostic systems. Design products for facilitated on-site repairs so that they need not be taken to the service centers. Design complementary repair tools, materials and documentation. On the strategy of facilitating reuse, increase the resistance of easily damaged and expendable components. Arrange and facilitate access and removal of retrievable components. Design modular and replaceable components. Design components according to standards to facilitate replacement. Design reusable auxiliary parts. Design refilling and reusable packaging. Design products for secondary use. Further, we have this is strategy of facilitating remanufacturing. So design and facilitate removal and substitution of easily expendable components. Design structural parts that can be easily separated from external visible ones. Provide easier access to components to be remanufactured. Calculate accurate tolerance parameters for easily expendable connections. Design for excessive use of material for easily deteriorating surfaces. So this is how actually we can allow the product to be like a remanufactured into some more like a some other product or some other like a design. So it's like allowing the preserving the actually the finishing of it, preserving actually the structural integrity of it, so that these parts as a whole or as a, like a component can go into like a utilize as a, like a remanufacturing like a item. Further, we have intensify uses strategy. So design product service for like a shared use, so that a number of people can make use of the same product, so that they need not buy it independently so many times. Design multifunctional products with common substitutable components. Design products with integrated functions. Design for products or product part on demand. Design for products or products parts on availability. So these are actually some actionable points which we saw under the like strategies for like a lifespan optimization, so that the product can be used for like a extended actually period of time. So this is how this can be facilitated. So design for like an extension of the lifespan. So design for like recycling, design for energy recovery, design for even composting. Further, in this topic we will discuss about materials recyclability, like a combustion, composting, etc. So it depends on like a specific material characteristics, performance recovery and cost of like a processes. Products like architecture, recycling phases, collection, transportation, separation, disassembly, or crushing, identification, cleaning, secondary raw materials production, etc. Let's see some strategies from like this actually topic. So for like extending the lifespan of the material, so there are four strategies listed down over here. Adapt the cascade approach. Select material with the most efficient recycling technologies. Facilitate end of life collection and transportation, and material identification. So for these, the actionable points are arrange and facilitate recycling of materials in components with lower mechanical requirements. Arrange and facilitate recycling of materials in components and lower aesthetical requirements. Arrange and facilitate energy recovery from materials throughout combustion. Well, further we have select materials that easily recover its original performance characteristics after recycling, so that it can be reused effectively in its like a after like a, the recycling. Avoid composite materials, or when necessary choose easily recyclable ones. The one point I have been talking like several times, we must actually go for simpler materials which are easy to like a dismantle or bifurcate at that time at the end of their life cycle. Otherwise it will become like extremely difficult to reuse them into like a some more ways. Engage geometrical solutions like ribbing to increase polymer stiffness instead of reinforcing fiber. Prefer thermoplastic polymers to thermosetting. Prefer heat-proof thermoplastic polymers to fireproof additives. Design considering the secondary use of the materials once recycled. The next, we can see this strategy of facilitate end of life collection and transportation. So this is one of the important actually strategies over here. Design in compliance with the product retrieval system so that it can be retrieved, minimize overall weight, minimize cluttering and improve stackability of discarded products so that they can be brought back in an like a efficient way. Design for the compressibility of discarded products so that again like optimizing on the space while like transporting and packaging. Provide the user with information about the disposing modalities of the product or its parts. Lastly, we have this strategy of material identification. Codify different materials to facilitate their identification. Provide additional information about the material's age, number of times recycled in the past, and additives like used. Indicate the existence of the toxic or harmful materials. Use a standardized materials identification system. Arrange codifications in easily visible places. Avoid codifying after components production stages. So these are actually standard actually procedures what must actually follow while actually packaging and labeling their products, so that this set of like informations are easily available on like a product package. So this will become very handy at the end of its like a life cycle stage, so that if it is like being taken for like recyclability or reusability or remanufacturability, so how and what are the components that can be actually used in those ways is can be like easily deciphered through these codes and like this informations. So I have taken some examples over here for you to understand, like to facilitating end of life collection and transportation, design for compressibility of like a discarded product. So this is one of the actually actionable points we discussed under this like a strategy. So you see like this actually a particular brand of these water actually bottles, they actually design their bottles in such a way so that after like they are discarded, they can be easily actually compressed in a like a smaller actually volume. So it becomes very easy and optimal for the recycler to collect these actually discarded water bottles and take it to the facility. Further, we have this example over here, minimizing the number of different incompatible materials. So use only one material per product or like a per sub assembly. So here if you see like this Herman Miller again is back with one of the very good examples. So the chairs like a back made with one material only. So the entire this back unit doesn't utilize actually a combination of like different materials, which is very difficult to segregate or dismantle them at the end of their life cycle. This whole unit of this bag can be again directly taken for like a recycling and dismantling, because this is a one actually single material altogether. So this is the one actually some examples we saw in the real life. So how such kind of like intentions can help in designing actually products with these thought processes. Further, we will see like extending the lifespan of the product over here. There are some more actually points given, some strategies are given over here which will facilitate actually extending the life cycle lifespan of like a product. So the strategies listed over here are: minimize the number of different incompatible materials, facilitate cleaning, facilitate composting, facilitate combustion finally. So integrate functions to reduce the overall number of materials and components. Monomaterial strategy, only one material per product or product like a per sub assembly. Use only one material but processed in sandwich structure. Use compatible materials that could be recycled together within the product or sub assembly. For joining, use the same or compatible materials as in components to be joined. So we saw in the like a previous example of this Herman Miller chair, so how the same material is used in the different components of the back. So minimizing actually the issue in like a dismantling and taking it off. For a strategy of facilitating cleaning, avoid unnecessary coating procedures. Avoid irremovable coating materials which cannot be actually taken out. Facilitate removal of contaminants. Use coating procedures that comply with coated materials. Avoid adhesives or choose ones that comply with the materials to be recycled. Prefer the dyeing of internal polymers rather than the surface painting. Avoid using additional materials for making or codification. Mark and codify materials during molding itself, so that there is no need of actually painting and putting up these coats later on. Mark and codify materials during like a molding, and codify polymers using like a laser, so that there is no like additional like a ink or such kind of like a complex actually pigments needed to put on those coats. Further, we have this strategy of facilitating composting. So select materials that degrade in the expected end of life environment. Avoid combining non-degradable materials with products that are going to be composted. Facilitate the separation of non-degradable materials. And finally, we have this strategy of facilitating combustion. So select high energy materials for products that are going to be incinerated. Avoid materials that emit dangerous substances during incineration. Avoid additives that emit dangerous substances during incineration. Facilitate the separation of materials that would compromise the efficiency of combustion with low energy value. So these are the actually points we saw over here. Like even the compounds such as like adhesives are very important to be like chosen like a judiciously, so that at the end of their life cycle they are not going to create a mess, while even if we are going for like incinerating or combusting them. So such is the actually level of sensitivity that is needed to address actually these critical issues. Finally, like a design for like a disassembly, so of for like a parts, components, product life optimization of materials like material life extension. So one of the actually beautiful examples taken over here for like a design for disassembly is this chair. So if you see like the reduce and facilitate operations of disassembly and separation, overall architecture prioritize the disassembly of more easily damageable like components. So this is this mirror seat actually from like a Herman Miller. So the most damageable parts and materials that can't be recycled together are the first and easy to be dismantled first. So you see like the all the components of this actually chair are laid out over here. So they are easy to like dismantle, disassemble. Okay, and accordingly they can actually recycle these parts or reuse these parts, depending upon their condition. So further we have for under the, like a last actually this set of like a strategy designed for like a disassembly. So we have three strategies listed down over here: reduce and facilitate operations of disassembly and separation, overall like architecture, shape of like components and parts, shape and accessibility of joints. So prioritize the disassembly of toxic and dangerous components or the materials. Prioritize the disassembly of components and materials with higher economic value. Prioritize the disassembly of more easily damageable components. Prioritize the disassembly of the parts that are more subject to technological or aesthetic obsolescence. Engage modular structures. Divide the product into easy separable and manipulable subassemblies. Minimize overall dimensions of the product. Minimize hierarchically dependent connections between the components. Minimize different directions in the disassembly route of components and materials. Increase the linearity of the disassembly route. Engage a sandwich system of disassembly with central joining elements. So these could be the actually actionable points to facilitate responsible actually disassembly and separatability. Finally, like with the strategy of like a shape of components and parts, so the actionable points are like avoid a difficult to handle components, avoid asymmetrical components unless required, design leaning surfaces and grabbing actually features in compliance with the standards, arrange leaning surfaces around the product center of gravity, design for easy centering on the component base. Finally, shape and accessibility of joints, avoid joining systems that require simultaneous interventions for opening. Minimize the overall number of fasteners. Minimize the overall number of different fastener types that demand different tools. Avoid difficult to handle fasteners. Design as accessible and recognizable entrances for dismantling. Design accessible and controllable dismantling points. So these are the actually they seem very like a, who cares for actually kind of like a points, but they are very important while a product actually goes for a disassembly. So you can take maybe a raw or maybe a discarded actually piece of furniture or any product in your house, and you try dismantling it and see like how you experience, for like a disassembly. So just imagine yourself as the recycler person who will be dismantling that unit by hand in some facility. So how easy that product is for you to like open it up so that you can divide it into like a number of like a components, you can segregate and send them for the like a responsible recycling. So you will understand like how important it is to consider these points for like a design for disassembly. Product life cycle design strategies. So the priorities, do some like strategies have greater priorities than others? For every product, some strategies have greater priorities than others. It is important to be able to properly identify environmental design priorities, and LCA tools can be used to support this task. Well, we have seen actually the number of strategies and number of like actionable points, like which one to employ, which one to actually apply, in which product. So that actually you also need to understand, so that is what actually we are talking about here. Which is the greater priority, you must actually like analyze before actually going to choose the relevant strategy for carrying out actually those tasks. So it is very important to understand. For example, a vehicle utilizes, like we have seen in the like LC analysis. So this is where actually LC analysis become very useful to understand the scenario of a product, like how it is performing over like a different life stages. So for example, an automobile actually consumes a huge amount of like a fuel over its entire life cycle. So the priority should be to minimize the fuel consumption. Okay, and for example, a chair, like we have seen in this like a lecture, a chair is used in a like a house or in an office, for like a definite actually purpose. The purpose is very very like a fixed and clear. So is it possible that we can extend the lifespan of it, so that we can keep on using for a longer period of time? Because the chair need not be actually changed just for the sake of it, or just for actually the going for like other like a silly reasons, so that I want to just change my interiors, I want to redo my interiors, or things like that. So these are actually very bad habits as far as like the habits and behaviors are concerned. And we have seen in the consumerism chapter how such kind of like attitude and behaviors are actually causing damages to the ecosystem. So we must actually control starting from the behaviors and habits to the like operations. And we must actually learn how to priorities and what are the priorities which actually must take care of while designing life cycle or the functional unit of a product. With this, we are almost at the end of this lecture. So this is the last actually topic of discussion over here. So about product life cycle design methods and tools. So in this, we will see there are some actually tools and methods and techniques given under the banner of this organization. The logo you can see at the left bottom side over here, LeNS. This is Learning Network for Sustainability. You can search this website. The address was actually given in the beginning. I'll give it again at the end of this presentation, and you can go to that website. You can register yourself as a student or as an academician or professional or researcher, and you will be able to download these tools and techniques and methods for like applying in your like design projects. So you can go for referring actually these books are this book is like available like freely to download. So these are like some of these books are actually developed as a like a common actually open source material for like a knowledge dissipation around like a in like SPSS, MSDS and DE actually techniques. Further, you can see like a MSDS, like a method for like a product design for environmental sustainability. So this actually table you can see over here. So this diagram actually gives us a flow diagram, like how to take a product design in like a phases. So you can see like a process and tools to orientate are given in this actually left column, and process tools on like a environmental assembly and this assessment are given on this right column, and how this exchange actually is taking place in between. So you see it starts from like the actually product strategies and the brief. So it goes on for like a LC on reference product for like a design, so this is SEMA Pro is one of the actually LCA tools which gives actually knowledge about conducting the LCA. Okay, and then from here you can go to this environmental design priorities identification, from where you can identify the priority areas where to intervene and how to intervene, and then you can go to sustainability focused like idea generation. You can go for like a conducting your brainstorming and this conceptualization, like how to go for the intervention. Further, you can go for the product concept development, etc., and you can go for like a abridged LCA check, further like a qualitative studies, qualitative like assessments also. Then you can go for like a check for sustainability design priorities. You can use these tools like IPSA and radar, etc., ICS, which are given on the this website of this LeNS Polymy. Further from here you can go for like a most promising like a concept selection. You can choose the best concept which seems like a relevant for the actually stage, and from here you can go for like a product design, and then again you can go for like average LCA analysis, impact reduction, etc., using these actually tools. And further again, for like you can go for like a low environmental impact process selection for like a manufacturing and a fabrication, etc. So accordingly you can use you can choose the tools and methods to undertake this exercise. And then further you can go for actually engineering the product, LC of comparison for environmental quality communication. That further lastly you can conduct another like a check for the its a final impact. So some of these tools and assessment methods are available free of cost to download and utilize in your like design projects. You can visit this website, you can register as a member, and you can avail these tools, and you can utilize them in your like design exercises. Finally, these are the actually reference materials, more reading materials on this concept of like SPSS, MSDS, and DE. I'm sure you would be happy to go and refer these. You can be a member also on this platform. It is a interesting actually platform from where you get to meet researchers and academicians and students from across the world, learning about their like approaches, how they are utilizing like a such like a wealth of this knowledge in their like a own context, how well you can do. So there is a lot of like a exchange also which happens periodically. So with this we have actually reached to the end of this lecture. Thank you everyone.